Welcome back, class. I hope you've had time to digest our first session. In our previous lesson, we defined the what, the nature of BIM as a data-rich process. Today, we move straight into the why. Specifically, we are looking at the historical issues of the construction industry and the global drivers that have made BIM an absolute necessity. If you don't understand the failures of the past, you are doomed to repeat them. For nearly a century, the construction industry has been the sick man of the global economy, while manufacturing became 200% more efficient through automation. Construction actually became less productive. Why? Because for over 100 years, we relied on a fragmented paper-based workflow. Historically, architects, structural engineers, and quantity surveyors worked in silos. You, the architect, would design a beautiful building in your office. You'd print the drawings and send them to the structural engineer. The engineer would then do their calculations, often ignoring your specific aesthetic details because they were just looking at load-bearing points. This led to information loss. Every time a project moved from one professional to another, about 30% of the relevant data vanished. By the time the contractor got the drawings on a site in Lagos or Port Harcourt, they were looking at a guess rather than a coordinated plan. Let's get specific. There are 4 major historical pain points that forced the world to move toward BIM. Historically, up to 30% of construction costs were attributed to rework. This means building something, realizing it's wrong, tearing it down, and building it again. The cause: poor coordination. For example, a plumbing pipe hitting a structural beam. The BIM solution: clash detection. We find the clash in the digital model for 0 naira, rather than on-site for 5 million naira. Because the traditional process was so fragmented, when something went wrong, the first thing people did was hire lawyers, not engineers. The architect blamed the engineer blamed the contractor blamed the client. The Nigeria context: think of the many abandoned projects you see across our cities. Many are not just due to lack of funds, but due to legal disputes arising from variations and scope creep, classic symptoms of a lack of a single source of truth. Construction is famously wasteful. In the 1990s, the Egan Report and the Latham Report in the UK highlighted that the industry was dysfunctional. They found that 10% of materials were wasted on site and 40% of projects were over budget. Historical failure: we were using 2D drawings to describe 3D buildings. You cannot accurately calculate the volume of a complex curved wall using a 2D plan. Historically, once the building was finished, the architect handed the client a box of paper drawings. Within 2 years, those drawings were usually lost or destroyed by termites. When a pipe leaked 5 years later, the facility manager had to break the wall just to find where the pipe was. BIM driver: the need for a digital legacy, a model that lives as long as the building. Around the turn of the millennium, governments realized that if they didn't change the industry, they would go broke building infrastructure. This led to global drivers. The UK mandate the world's benchmark. In 2011, the UK government published a construction strategy. They realized they were paying too much for schools and hospitals. Their driver was cost reduction 20%. They mandated that by 2016, all public projects must be BIM level 2 compliant. This forced the entire global supply chain to learn BIM. The sustainability driver: the green agenda. Climate change is a massive global driver. We can no longer afford to build buildings that leak energy. The metric: you cannot manage what you cannot measure. BIM's role: BIM allows for building performance analysis. We can simulate how much carbon a building will emit before we even buy the land. Global competitiveness: if a Nigerian firm wants to design a stadium in Qatar or a high-rise in London, They can't show up with AutoCAD files. BIM is the global language of construction. To participate in the global economy, you must speak the language. Now, let's talk about us. Why is BIM so critical for Nigeria specifically? Preventing building collapse. This is our greatest shame as built environment professionals. Every time a building collapses in Lagos or Abuja, it is often due to a failure in coordination or compliance. Driver, BIM allows for a digital paper trail. You can see exactly who designed which beam and whether it was checked. It forces a level of discipline that traditional methods lack. Managing inflation and cost volatility. In Nigeria, the price of iron rods or cement can change between Monday and Friday. 5D BIM as a driver. Because BIM gives us automated, real-time quantity takeoffs, we can react to price changes instantly. We can swap materials in the model and see the cost impact immediately, helping our clients make faster decisions in a volatile economy. Transparency and anti-corruption. One reason projects in the public sector often go over budget is ghost quantities, charging for materials that were never used. Driver, BIM makes it very hard to hide. If the model says there are 400 windows, you can't easily bill the government for 600. It brings transparency to procurement. Research from organizations like BIM Africa and the Association of BIM Lagos shows that while awareness is high, actual deep adoption is low. Most firms are still in lonely BIM, where the architect uses BIM but doesn't share the model with the engineer. This is a historical hangover. We are still afraid to share our data because of IP concerns. But listen to me, the value of BIM is in the collaboration, not the 3D model itself. I wouldn't be a good professor if I told you it was all sunshine. There are real historical reasons why people resist BIM. 1. The learning curve. It is steep. It's not just a software, it's a change in your brain's operating system. 2. Infrastructure issues. In Nigeria, we deal with the triple threat: unstable power, slow internet, and high software costs. 3. Interoperability. Sometimes the architect's software doesn't talk well to the engineer's software. This is why we rely on IFC industry foundation classes. To wrap up, we've looked at how the historical issues of fragmentation, waste, and lack of productivity created a perfect storm that necessitated a new way of working. We saw that global drivers like government mandates and sustainability goals are pushing the industry forward, and that in Nigeria, BIM is our best hope for solving issues of building collapse and cost management. You are the generation that will bridge this gap. You are moving from an era where we drew buildings to an era where we manage buildings. Your task for this week: I want you to research one major building project in Nigeria that was either delayed or abandoned.